We've talked about the normal distribution and the way it forms this type of bell curve. And now I'd like to talk about the standard normal curve. The standard normal curve is often given a variable of z. And what's unique about the standard normal curve is the mean is 0 and the standard deviation is 1. So we're going to note that down. The standard deviation is 1 and the mean is 0. We often use the standard normal curve to standardize or to compare two sets of data that might be in some way different and otherwise very difficult to compare. So if you imagine two different schools doing a maths methods SAC, for example, and one setting an easy SAC and another one setting a difficult SAC, what you can do is you can start using the standard normal curve to compare results on a more even basis. And this is how you do it. Let's imagine we have school A, and I'm going to put this here, school A, and the mean for school A's SAC mark was 84%, and the standard deviation was 7%. I could put those marks or those levels down in this standard normal curve underneath here. So everything from school A is going to be in blue. If the mean is 84 and the standard deviation of 7, one standard deviation above the mean is going to be 84 plus 7, which is 91. Two standard deviations above the mean is going to be 98, and so on. And then if I go below, I get 77 and 70, and so on. Now, my standard values you can see in yellow. And so therefore a student at the blue school, school A, who scores 77 is one standard deviation below the mean. Now I have another school. Let's put this one in orange. This school, school B, wrote a much tougher SAC and the mean was 50%. The standard deviation was 15. So what I can do is I can put this school's SAC results underneath as well, where my mean here is still 50 and one standard deviation above is 65 and two standard deviations above is 80. You can see that a person who did this SAC at school B getting a score of 80 would be two standard deviations above the mean. That means they would be approximately in the top 2.5% of students. Whereas a student at the blue school, school A, who scored 80% on their SAC, would be below the mean. So this is how we can start comparing our results. Now what we can do is we can consider a student's score. So let's imagine at the orange school, a student got 60%. If this student scored 60%, then we would expect that their standardized score is somewhere here. And their standardized score is actually able to be calculated. The standardized score is the student score minus the mean all over the standard deviation. And so in this case, this student who scored 60, their standardized score would be positive 2/3 or positive 0.6 with a lot of sixes following it. Now, this is my yellow number. We've suddenly converted an orange number of 60% into the yellow number of positive 2/3. Now I could consider exactly the same student at the blue school, school A, who had a Z score of positive 2/3, and see that the score for positive 2/3 here looks like it's about 89%. And you can see that in this way we can compare two completely different sets of data by using the Z scores, by using the standard normal curve to convert in and out of two different comparisons. It's critical that you become aware of and can use this formula. This formula is what relates my standard normal curve, the z-score, to a unique set of data that has its own mean and standard deviation. So by using the standard normal curve, we can compare different sets of data. Remember, the standard normal curve has a mean of 0 and a standard deviation of 1. And the way to convert from a set of data on its own normal curve to the standard normal curve is using this formula. And we can obviously use this formula to convert to and from the standard normal curve. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.